Hi everyone, in this video we'll be looking at question 35 from HSC Standard Maths 2020 exam. This question came from the topic of normal distribution. Generally tricky questions, and this also was a bit tricky. One of the things you should be very good at when it comes to normal distribution are all the empirical rules, because they are tested quite widely, and this question was also not an exception. You've got the IQ score for adults for city A, which is normally distributed, and mean and standard deviation is given. We also got for city B as well, mean and standard deviation given for normal distribution IQ score. We are told that Ian is an adult who lives in city A and has an IQ score of 128. And it's asking you what percentage of adults in city A have a higher IQ score than Ian. So let's take this question out. This is all about using empirical rule here. You need to know that when a distribution is normal distribution, then there are certain things that it's supposed to have. So we talk for part A we are talking about city A, right? So city A has a mean of 108. So this is 108, and if this is the distribution, what empirical rule says is that 95% of the values would lie 95% of the values would lie between two standard deviations. So two standard deviations is 108 plus 2 multiplied by 10. Standard deviation is 10. So 128, and 108 minus 2 times 10, which is 88. Okay. So what it's saying is that between 88 and 128, this area, 95% of the values are here. This is the empirical rule you need to know. But the question is asking what percentage of the people have IQ score higher than Ian. So what the question is interested in is, because Ian's score is 128, which aligns very well with this 128 from the empirical rule, it's asking is this value, what percentage, this value, so call it X, percentage above 128, higher than Ian's IQ. So if the center bit is 95%, then the bits that are outside this bit and this bit, sum of these would be 5%, 100 minus 95, and because they are equal, so the answer to part A would be X, which is 5% divided by 2. So 2.5% of the people in city A have higher IQ than Ian. Then coming to part B, there are 1 million adults living in city B. Calculate the number of adults that is expected to have IQ score lower than Ian. Now again we need to use an empirical rule, but here the distribution is different, right? So the mean for city B is 112, and if you plus 16 over here, it takes you to 128. 16 is the standard deviation, 112 is the mean, and if you remove 16 over here, it takes you to 96. Okay, so this is one standard deviation. Empirical rule says that within one standard deviation, 68% of the values lie. 68% are here. Now the question is asking the expected number of people having a lower IQ score than Ian. So what it wants you to do is first calculate the probability of people that are below 128. So again, we're going to use the same logic. The people that are outside, either above or below, above 128 or below 96 would be uh, the remaining bit. So 100% minus 68% is 32%. So here is 16%, and 16% would be here. So when it comes to the question, what we need to answer is percentage below 128. Below 128 would be this 68%, which is between 96 and 128, and plus this 16%, which is below 96. So people below Yin's IQ would be 68% plus 16%, which would be 84%. Now the question is asking expected number of people, so you multiply that with 1 million. So 1 million times 84% would give you 840,000. So these are the number of people in this town that have an IQ below Yin. Now coming to the final question, final part. Simon is an adult who lives in city A and moves to city B. Z score corresponding to IQ in city A is the same as Z score in city B. So we need to find IQ of Simon. So let's calculate the Z score in city A for Simon. Let's call Simon's IQ score, IQ of Simon, as X, okay? Then the Z score would be X minus the mean. For city A, the mean is 108 divided by 10, which is the standard deviation, is equal to, it's saying the Z score is the same. So for city B, the Z score A would be X minus 112, which is the mean, divided by standard deviation, which is 16. Now you play around with this and solve this, and you will get X equal to 101.3. So that would be our answer.